Okay, today we're going to talk about the rational zeros test, also known as the rational root theorem. And this will help us identify possible rational zeros of a polynomial function. So let's begin. Delete. Okay, so again, like I was just saying, this could also be called the rational root theorem. And let's see what it says. Okay, the rational root theorem reads, if polynomial f of x equals, this is our polynomial notation here, a sub n x sub n plus, and as we have descending order of exponents, all the way to our constant. If the polynomial has integer coefficients, and that's a really important detail here, that all of these coefficients in front of our x terms must be integers, then every rational zero of f has the form p over q. So two things. You're probably wondering what P over Q are, but I just want to remind us what rational numbers are. Rational numbers are numbers that can be written as fractions. So for example, 4 is rational because that's 4 over 1. 3/2 is rational, even negative rationals. But it can be written in the form P over Q, where P and Q have no common factors other than 1, and P is a factor of the constant, and Q is a factor of the lead coefficient. Okay, so for example, we have this polynomial. If I can find all the factors of my constant divided by all the factors of my lead coefficient, those are the possibilities of what my rational roots could be. So I'd like you to put that into your own words here. So think about that, write it down. Okay, so let's practice. It says list the possible rational zeros. We want to find all the zeros and then state the x-intercepts and write it in completely factored form. So let's have you go ahead and try that out using the rational root theorem. I would suggest starting by listing off the factors of p, which would be the constant. What are all the factors of 9? Then I would write out all the factors of my lead coefficient, which in this case is 1. To get us started here, I know that the factors of 9 would be 1, 3, and 9. Now notice that I'm putting plus or minus because negative 9 does divide into positive 9. The factors that divide into 1 would be plus or minus 1. Okay. So then my possible rational zeros would be P over Q, which is basically going to be 1 over 1, 3 over 1, and 9 over 1, which is 1, 3, and 9. So that's one part to answering the question. Let's have you guys find the x-intercepts and then write the function in completely factored form. Go ahead. Okay, so I found that the three zeros of my f of x function here is -1, 3i, -3i. I found that there's a couple things you could do here, but I found this by using factoring by grouping. Now, because 2 out of the 3 are imaginary, my only x-intercept is -1, 0. And last but not least, writing it as a product of linear factors would be x plus 1, x minus 3i times x plus 3i. So in conclusion, just remembering how to find our possible rational roots, we can use that rational root theorem. Oopsies. We did find that one of in this example, -1 was one of our zeros, and that does follow within our list. Remember, these are our possibilities. It's possible that one of these, really 6 options here, could be a rational root, and one of them happened to be.